Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life. Bonus edition.
I have my guns up ready to go.
This is our bonus episode.
This is our bonus episode. And guess what? There were so many good questions from our listeners just off the cuff that I didn't even have to post an Instagram story soliciting them.
Wow. Interesting.
So good job, listeners. Thanks for caring and sending questions. We love it.
Very cool.
So first, I'm going to share a fun fact that came from Carol, the English coach.
Okay.
She used to have a podcast where she would teach English. I don't know if she does anymore, but it was so soothing that sometimes I would listen to it to fall asleep.
Nice. I don't know if I remember that she did the podcast. I do remember her having videos.
Yes, she does. And she uses science sometimes to teach English.
Right.
Yeah, she's a real fun account to follow. So she sent us a really cool article from Chemistry World. It's a magazine that is put out by the Royal Society of Chemistry, sort of the European equivalent of the American Chemical Society. Or I guess the American Chemical Society is the American equivalent of the European one. Who knows?
Yeah.
And anyway, so she sent us an article by them about a U.S. startup company that made tattoo ink with biodegradable polymers that break down over time. And so these tattoos fade. So because we already know how tattoos work, do you remember how tattoos work, Jam?
The ink is these large compounds, something. I forgot
Large molecules.
Large molecules. And our bodies can't break them down.
Yep.
But the systems we have in place that would break them down basically end up realizing that, and they decide to keep them in place because they're like, unknown entity. We can't break it down, but let's sequester it.
Yes.
Here.
Yeah.
Basically. Is that correct?
That's correct. And so that's how these same ink, these fading tattoos work initially.
Okay.
But because they're so big over time, bacteria and other things can break them down because they're biodegradable.
Okay.
And so over time, they eventually get small enough to where our body can take them away and can do away with them, our immune systems.
Okay.
So they're semi-permanent tattoos.
Did they give a time frame? Like how?
I think a few years.
Okay, that's kind of cool.
And it's fun because it's like they knew the chemistry of tattoos, but I think for religious reasons, they didn't want permanent ones.
Right.
So they used polymer chemistry and the body to solve their problem.
I think that's awesome.
And since we know about how the chemistry of tattoos work, we can understand what they did too.
Yes. I think that's crazy to think that this hadn't already been done in a way, you know?
I know.
Because I think there's a lot of people who may have thought, I'll get this tattoo. I'll get the semi-permanent. If I end up loving it still, a couple years later, I'll just get it again, but permanent. Or keep doing semi-permanent. I mean, who knows? You know?
I thought about doing that with my wedding ring. I want a tattoo there, but I'm afraid it would make the ring look weird. Because my ring's is really thin.
Yeah.
And so then I'm like, would that be weird? I don't know. So like a semi-permanent one would be the perfect solution.
Yeah, you don't have to fully commit, but you still get the benefits of it, not being gone next week.
Right.
That's awesome. Very, very smart.
Very smart and very cool. Thanks for sharing that, Carol. I love that we understand the chemistry behind tattoos and that we understand how this problem-solving process worked to get the semi-permanent ones.
Yeah, that's genius.
Yeah, so thanks for sharing. That was really fun. I loved reading that.
This next question we have is from Ebony. Ebony asks, in the fridges at work, we have thermometers for food safety recording, but they're in a glass of water. So would they be accurate with water and air having different specific heat?
I love this question.
Whoa.
So, Ebony, this is a really good question. I love that you're looking at the world and thinking about the chemistry that's going on. How delightful. So, I think your initial understanding is right. The air and the water would change temperature at different rates. So, it might be cooler in the water because it can hold on to the temperature better. But I think what the water does is maybe mimic the temperature of the food itself. So if you imagine like a soup that has a high water content, it also probably has a different specific heat than the air around it.
Right.
So sometimes, if you have a cold drink, it's heating up slower than cold air or something. And so it'll stay cold longer, right? So I'm guessing that what they're trying to do is mimic the food's temperature.
Right.
And not the temperature of the air to see, did the food get to a temperature that's not safe?
Right. That makes sense, because I guess if you open a fridge say you have it open for 30 seconds, potentially the air in the fridge could undergo a significant temperature change.
Especially depending on maybe the air in the door.
Right. But a lot of the food may have only changed the slightest bit, and then you close the door again and it goes back.
Yep.
So it might be more accurate, but that's crazy. I didn't think about that.
I hadn't thought about that either. So if you were really, really worried and you wanted to be super safe, I guess you could go with the air temperature. But I do think that what they're doing, especially for liquids, is not a bad method. It might not be the most accurate, but I feel like it's probably closer than the air temperature. What a good question.
Yeah, seriously.
That was fun. Thanks for bringing that up, Ebony. Ebony's been with us from the very beginning and wrote kind of a sweet message about how I remember their username on Instagram was funny. So I remember talking to them at the very beginning, but pretty recently they wrote us a sweet message about how much fun it is to think back about when they first started listening to the podcast years ago and how much has happened since then. So that was really fun.
That's cool.
Shout out, Ebony.
Yeah, we have the best listeners, I guess. I guess the thing is, I feel so sorry for all the other podcasts.
Yeah. It's really a bummer.
I'm
one of those other listeners of other podcasts.
Yeah, me too. I mean, I just feel sorry for them. Like, they don't have the listeners that we have. So
yeah. We've actually made friends through this. It's been really fun.
This next one is from another listener who's actually been with us for quite a while, Avishai. The fun fact / question. In the latest bonus episode, you answered the question of why pasta with red sauce stains plastic containers. There is a nice trick to clean that red stain. Put soap, water, and a piece of paper towel, close the lid, and shake it. But why would it work better than scrubbing, and what is the role of the paper towel? That's the question.
Okay, so Avishai took a shot at answering it, and I think he has a master's degree in something, doesn't he?
Something. I don't. This is one of those things where sometimes I get.
I think Avishai is also a scientist.
Yeah.
So Avishai thought off the cuff that this is a solubility issue. So if you increase the amount of solvent, then you can thermodynamically dissolve more of the chromophore. When he says chromophore, he means the red thing, the pigment.
Okay.
Using the oil to allow for hydrophobic molecules also to dissolve, because you put the soap kind of has something that attracts oil out.
Right.
The mixing helped increase the amount of fruitful meetings between oil, soap, and water. The paper towel is the tricky part. I believe it's due to Le Chatelier's principle, absorbing the generated soap chromophore micelles and pushing the dissolving reaction forward. So basically he's saying if we have a lot of the solvent, which is the water, that we can have more likelihood that it'll interact with the oil and the pigment that are trapped in the Tupperware or bonded to the Tupperware, and that'll pull it out. And then Le Chatelier's principle is if you remove the product, then more product will sort of be made. And I loved the way that he was thinking about the chemical concepts and thinking about what was underlying, just like with Ebony. I was really excited about that. And I really hope our listeners keep up this habit where they look at the world and they think about questions and then think about the molecules at the base level. That's like always my dream. I remember the time Jam figured out the the tires. I was so excited. But I'm not sure I fully agree with his assessment, just because I don't know what would be different about the paper towel versus dumping out water. So I see what he's saying, like, if you just let it soak and you shake it up, then that does have more solvent for the stuff to dissolve in and more likely for the molecules to meet the soap and all that. But is it more than if you were to scrub it? I just don't know.
Right.
If you're to soak it and scrub it. And I don't know why something would bond to the paper towel and not just dissolve itself back again in the water. So I feel like I'm still not 100% sure about this hack, but I really like the way he thought about it. And I wanted to put it to our listeners or other scientists. if they have thoughts on how this hack might work. I've never used this trick, so I don't even know.
Yeah, it's interesting. I feel like I would love to see a video or try it myself, because then at least if we can prove that it does work, not saying that it doesn't, but I just, it's one of the things like it makes a difference when you see it, and like maybe something as obvious when you watch it happen.
Yeah, like the paper towel turns a color.
Right. Like if it turns the reddish color, whatever.
Yeah.
But it seems like just on the surface, I feel like the things I've tried to get red staining off of some Tupperware didn't work. And so, and I've scrubbed hard and used a lot of soap and this kind of stuff. So it's just, there's a little bit of this doubt I have of any hack that might work, but I'd love for it to be true. And then if that was the case, maybe we could get somewhere about why it works. But
I've also shifted away from the plastic Tupperware, and I know you mostly have too.
Yes, definitely.
And I pretty much exclusively use glass things now, glass containers.
Yeah.
Just because of what I learned about plastic.
Right.
In that.
Yeah.
In that fateful series that we did about recycling that changed my life forever.
That fateful series.
Yeah. That and the cast iron, I think, are two we didn't see coming, but they got us good.
Oh, yeah.
Okay, so great question, Avishai. I love the thought process, and I loved how you zoomed in on the molecules and thought about it at that level. And I hope more of our listeners keep doing that.
Yeah, and if Avishai or you or any of our other listeners has actually like seen some video of this happening or something like that, we're like, I don't know, I'd love to see it. So send it to us or whatever.
I'd also love to see it.
Yeah. Well, I'm not. Maybe I'll show you. Just send it to me. I'll decide.
Jam barely gets on our socials, so he will, unless it's on Facebook, he won't be the first to see it.
And I don't even really get on Facebook. It's just that I get notified about that one easier. But
I can't get on Facebook because Facebook knows I'm an imposter.
Yeah.
So I've tried to get access to our Facebook, but it's very difficult for me. So
yeah, it's the one I'd love to delete. I just can't quite fully delete it for a bunch of reasons. Anyway. Okay. All right, Mark Zuckerberg. This next question is from Emerson. Emerson asked, why can't Clorox/household bleach be used to dye hair? Speaking from personal experience, do not try that at home. Oof.
Emerson.
That sounds bad.
That made me laugh. Okay, so first I want to shout out Emerson because they're one of our Patreons and they asked this question a while ago and I forgot to, I think I didn't get it before we recorded. So they asked it last month and I didn't see it. Thanks for your patience, Emerson. Here's my attempt at an answer. So bleach is very basic, and bases, like acids, are caustic, which means they can damage, burn, break things down chemically.
Mm-hmm.
And so that can be rapid and painful if it's on your body. So like acid burns, bleach burns, that's what those are from. And so what bleach literally does is dissolve your hair using a chemical reaction, and like household bleach.
Right.
You shouldn't have it anywhere near your body, really. And I'll say that basicity is often characterized by having a high concentration of OH minus, that's an ion. So a good way to imagine this is if you have a water molecule, so 2 hydrogens and an oxygen.
Mm-hmm.
And if you split those up, and one hydrogen is off by itself and it didn't get any electrons. So it's looking for electrons. And then on the other side, the oxygen and the other hydrogen are together and they got all the electrons.
Mm-hmm.
So they're looking to react with things to give their electrons away. And the hydrogen that has nothing is looking for things to get electrons.
Okay.
So hydrogens with no electrons around them, that's acids. And so they tend to be reactive because they're trying to find the rest of the electrons that they want.
Mm-hmm.
And the oxygen and the hydrogen, those are hydroxide ions. They have a lot of electrons to give away. And so those are also pretty reactive. So the basic ones are the OH with extra electrons, and the acidic ones are the ones that are looking for electrons, basically.
Mm-hmm.
And both of them can be very reactive, and both of them can do a lot of damage. So I think sometimes people think, oh, acids are bad for you. Acids are caustic, blah, blah. Bases are the same thing, basically. They're also going to do all the bad, scary stuff. So that's something actually our listener Bree had chimed in on the question on our Patreon and mentioned that she thought that that's what was going on with the bleach. And that is part of it. As part of it, there is some hydroxide, those OHs that are scouring for all the hydrogens without electrons that they can find or places that they can give their electrons. And that will mess up your hair.
Okay.
And actually, sodium hydroxide is the main ingredient in drain cleaner, hydroxide. So it gets in there and, does a big reaction and tries to mess up the hair.
Yeah.
But household bleach also contains something else, which has this like very classic bleachy smell, is called sodium hypochlorite.
Uh-huh.
And that's even more confusing because instead of an oxygen and a hydrogen, it's an oxygen and a chlorine.
Okay.
And it's very reactive and it scavenges even more intensely. And it's called an oxidizing agent, but it does something really similar. It breaks bonds, it's reacting, it's just out there trying to react with stuff.
Yeah.
And so both of those things can dissolve your hair. But the bleach that they use in salons or like that's sold as hair bleach is actually neither hydroxide nor sodium hypochlorite. It's something different. And they just call it bleach because it gets rid of the color.
Okay.
So, there's the bleach that we use in our household chemicals, and then it gets rid of color for the very reason we talked about a long, long time ago in our How Does Bleach Get Rid of Color episode.
Uh-huh.
But it also gets rid of a bunch of other bonds. And then there's hair bleach, which is much gentler, but does get rid of the hair color. And so basically the gentler hair bleach only breaks down those pigment molecules.
Right.
And it can do a little bit of other damage if you've heard about how bleach can damage your hair, but that's the biggest thing. It's gentler and it's more targeted, I would say.
Interesting. Man, that is crazy. I mean, I've never tried to bleach my hair. And I didn't know until the question was asked that you can't just use household bleach. I mean, I probably would have deducted that, like, it's probably not a good idea and it would be something you'd want to look into before you tried it.
Yeah.
But I wouldn't have thought that it would be that big of a difference.
It's a big, big, big difference. And actually, don't use bleach on your hair or your skin and don't mix it with other chemicals because there are some other household chemicals, like acidic ones, that it can react with really violently. And it can even make chlorine gas, which I believe is the same gas as mustard gas.
Oh.
So you should not mix bleach with other chemicals. Like it's very, very dangerous. Bleach is a serious household cleaner. So be really careful. I don't know. Have you ever got bleach on your fingers and your fingers felt slippery?
I don't know if I have, but I have used bleach a bunch, but I don't know if I've done it.
That's happened to me. Like if I'm cleaning and I like put the cap on and I get a little, and it's like, I think that feeling is it dissolving that layer of your skin.
Oh, weird.
But somebody told me they thought it was maybe making soap because it's similar to the soap reaction, but I don't know. But either way, the slippery feeling when you have bleach on your fingers is like, so yes, bleach, you should be very, very careful with it. But also there was a ton of information about hair bleach. And so I'm hoping I can do an episode about it. Its own episode. So I'm going to keep some of that close to the chest.
Nice.
But it was really fun, because Emerson asked on Patreon and then I didn't have a chance to reply and Bree responded. And then I got back to our Patreon after the Christmas break and saw that had happened. And so it's just kind of fun to see our community like sort of take on a life of its own and people talking to each other about science. So
yeah.
That was really fun. So thanks Emerson and Bree, and thanks for letting us see that little interaction.
And here's another question from Emerson also. Why don't black and gray tattoos typically show up in tintype photographs?
Well, guess what, Emerson? I don't even know what a tintype photograph is, but Jam is a radio, television, and film expert, so I'm putting Jam on the spot. Do you know what a tintype photograph is?
I know what it is, but on the chemistry side, I've actually, one of the questions I had submitted at some point was specifically that we would talk about film and instant film, that kind of stuff. And so
film is complex.
Yeah, and I don't have a ton of depth of knowledge on the chemistry side because I've just needed to know what I've needed to know about it. And I am into film photography and stuff, but I've never done tintype. I've seen them, and I know what you're talking about just in the sense that, like, the way it understands...
Wait, can you tell us what tintype is first?
Nope. Can't tell you.
Can you give us the vibes or, like, what does it look like or anything?
I have no idea how to tell you.
Okay. Does it have a specific look to it, like film versus?
Yes.
Okay, so should we just all right now collectively go Google tintype photographs?
Yeah, they look different. It's like an older school way of doing it. I want to say it's literally onto a sheet of metal.
Okay.
Is the
Oh yeah, these like old timey looking ones.
yeah. Our we have a friend, Melissa and I have a friend named Sean who actually has had a tintype photo taken of him and his wife.
Oh.
He's the only person I
Sean
know.
and Vianette who came on the show.
Yep.
Wow.
Yeah. I'm not sure if he knows either. He never listens to our show, and so he's not allowed to know about
Yeah, you really
chemistry.
should have phrased that. Our listener Vianette and her husband Sean.
Yeah, who we kind of know. They have had a tintype photograph taken of them, and what's crazy is if you know somebody in real life and you see a tintype photo of them, there's an odd, very different way that it understands and treats light.
Interesting.
That is hard to put your finger on. And so what's tough is if you see a tintype photo, you might kind of pick up on that a little bit, but you might not if you don't know what that person looks like otherwise.
Yeah.
So Sean and Vianette are ones that I actually have the ability to know that with, and not anybody else. Like,
okay.
but I just don't know how to describe it. It's like
Yeah.
it's understanding and the light, the way it's affecting the way the image shows up is just different.
Okay, well, sorry, Emerson. I thought that maybe Jam could shed light that then I could shed back, but I have a rule that I don't do research for these episodes because it's too much. It's too much. I used to say I'm a grad student, but now I'm not. But I have another job, so sorry that's not a satisfying answer. But I do want to shout out Emerson because Emerson works with the other Dr. Kalini, and she's also a Patreon supporter. So thanks for your questions, Emerson. And the fact that I have no idea what tintype is made me laugh. And I really enjoyed thinking about those things. So thanks. And tell my sister I said hi.
This next question is from another one of our patrons, Tim. What kind of fluid is ferrofluid?
Okay.
Never even heard of this, I don't think.
You've never heard of ferrofluid?
I don't think so. If I have.
I bet you have. So again, we can all Google together, but ferrofluid is like black liquid that's magnetic.
Oh, yeah.
Yes,
Okay.
you've seen it. And it does like weird spiky things like this.
Yes.
Okay.
Totally. Yep.
So, and I've seen ferrofluid in kids' museums and on YouTube, and I don't even know where all. Just like, I feel like I've just seen it around. It's kind of a cool gimmicky thing.
Yeah. It's crazy.
So, ferrofluid is what's called a colloidal fluid, and we've had other colloidal fluids that we talked about on the show. Can you think of one?
Colloidal fluids. We talked about on the show. Can I think of one?
Do you want me to describe what a colloidal fluid is?
Yes.
It is when you have really small particles suspended, evenly distributed in a carrier fluid.
Tattoo ink.
Okay, that's a good one. I think that could just be a suspension.
Isn't that what you said? Suspension?
I think it has to be a specific size, maybe. Let me look. Let me see if I can find out.
Okay. What other fluids? I'll just start listing fluids. I'll just stop. Pee, poop, blood. I'm just kidding.
Okay. I found the difference between a suspension and a colloid.
Okay.
Okay, particles in a suspension can be separated by filtration, unlike those in a colloid. So I don't know if ink is a colloid or not.
Okay.
I'm going to guess not because they're big pieces.
Right. And it seems like maybe you could filter it out.
It does seem like that, but I don't know for sure.
Okay.
But there's a different one.
Okay.
Do you want me to tell you?
Is there a hint you can give me? Is it larger than a loaf of bread?
It's whatever size you make it.
I was just trying to go with that standard 20 questions thing.
I don't think I can give you a hint. I can't think of a good one. I think oobleck should be a colloid because the particles are too small to filter out. But maybe if you had a really fine filter, you could.
Interesting. Oobleck, right.
Because
right,
cornstarch is such small particles. It's so fine.
Right. Right.
But maybe if you had a really good filter.
Yeah, that's tough.
So anyway, all that ferrofluid is a colloid, or a really, really small suspension of particles that are evenly distributed in a carrier fluid, and they happen to be iron and magnetic. So ferrous is another way of saying iron.
Okay.
So that's it. And so it looks like a liquid that acts magnetic, but I think it's actually just tiny, tiny magnetic pieces.
Oh, interesting.
So there you go. And
Fe is a symbol for iron?
yes.
There we go. Ferrous.
Ferrous, yep.
Got it. Makes sense.
Mhm. And there's like a joke where people are like, what do you call a wheel made out of iron? The Ferris wheel. Anyway. And on that same topic, Tim also sent us a message on our last Q&R. We talked about honey mustard and if it was non-Newtonian also.
Right.
And so Tim followed up. He sent a video from Sugarology, which is a YouTube channel. She's a scientist of some kind, I think, and she has a baking channel. And she posted a video where she called ketchup a thixotropic liquid, which is, essentially shear thinning.
Right.
So there's another tidbit you can add to your kinds of fluids mindset.
Thixotropic.
Thixotropic.
Is it like a category within non-Newtonian? Because I know we talked about ketchup in that episode.
I don't know. She just said it, and I thought, is that just another shear thinning word?
Right.
Anyway, so I thought that was fun. And if you're interested in science and baking, Sugarology could be a good channel for you. Okay, so this was a lot of fun questions. And like I said, I didn't have to post an Instagram story. So we didn't get any of the more random type questions we get. And the person who always asks those is Renee, the other Dr. Collini.
Yes.
So I reached out to her and she said, oh, don't worry. I'm in a room full of facilitators. I can get you a good icebreaker question. So the one she said is actually from our mutual friend, Allie. And I love the question and I'm so excited. Okay. Allie wants to know, what is your least favorite shape of pasta?
Wow. What a specific question.
Dude, I have strong feelings about this.
You do?
I do.
Huh.
And I have strong feelings about what my favorite shapes of pasta are.
Interesting. I wonder if I'm realizing right now that I don't care.
I eat pasta a lot.
I love pasta. I absolutely love pasta. And I love having strong opinions about things. And so do you. Melissa and I are similar in that there are things that we get a lot of enjoyment about having a strong opinion about that one could argue are not that important.
Yeah, but we would never. We would argue.
Let me hear your answer and
Okay.
why, and then maybe something about it will make me have an opinion too.
Okay, well, part of this has come up recently. I've been traveling a lot for work, so I've been eating in restaurants a lot again lately. And when I was in Louisiana, I had this really good seafood Alfredo type pasta, and it was on penne pasta.
Yes.
And the distribution of sauce and meat and stuff was so good. And then we came home and we went out to eat for my brother-in-law's birthday. And we went to another similar seafood type restaurant, and I ordered this pasta. And instead of penne, it had these wide, flat, slippery noodles.
Okay.
And I hated them.
Okay. That is fettuccine, correct?
No, it wasn't
wide,
fettuccine.
flat?
It was wider than that.
Whoa.
Let me look up the name of it.
Wider, flatter. It was all one big flat noodle.
It was probably like an inch wide and very thin.
Interesting.
So fettuccine is a little bit thicker than this one was, and it's like closer together. And I'm okay with fettuccine.
Yeah.
It's like, I'm fine with it, but I'm not like in love with it.
Yeah.
But I was annoyed at this. And then as I started thinking about this question, I realized like, yes, there are pastas that I want and pastas that I don't. So like the mac and cheese that has like the fun shapes, like, oh, the shape's like a cartoon character. Hate it.
Interesting.
The texture of it's all wrong and weird. I just, no, thank you.
Interesting.
So yeah, I have strong feelings. Like some things I'm like, no, why would you put sauce on that?
Right. That's so strange.
All of our Italian listeners are like miserable right now. They're like, you guys don't even know what pasta is.
Yeah. I think if I had to force myself to have an opinion, I would just say that like standard old spaghetti noodles are like my least favorite because they're the least interesting to me. They're the most normal. Like I would probably prefer angel hair compared to standard spaghetti, you know?
Okay.
But I also love penne. The distinction's kind of lost on me a little bit, but ziti uses.
Ziti, I think ziti is like fatter and bigger around.
I think some places it is, but some places use the word ziti, and they actually using penne.
Yes.
Love ravioli. You know, I could take or
love
leave.
Ravioli.
I could take or leave manicotti, probably.
Tortellini is good.
Tortellini's
Manicotti is. I mean, it depends what you stuff the manicotti with.
One of the reasons why I might leave manicotti and not keep it is just that there's been a few times I've had it where part of the shell is a little hard because they bake it as well,
Mm-hmm.
and it gets a little tough, and that's not my favorite. Not like al dente, but like it's like in the baking process is hardened.
Yeah, it gets crisped up again.
Yep, and I don't love that biting into a kind of baked, crisped up piece of pasta once.
Yeah.
When the rest of it's not that way,
Weird.
that's unpleasant. But yeah, that could just be the way it's made. Not all manicotti is probably like that. But
The pasta that I didn't like is called pappardelle.
Pappardelle.
Pappardelle. And I feel like maybe with a thicker sauce or a different setting,
mm-hmm.
it probably has its place to shine. But it was a big old disappointment after the Louisiana seafood pasta.
Yeah. That's a bummer.
So
Dang, interesting question.
yeah, it's also interesting because it's like, yeah, I realize that I do have strong feelings about this, and apparently you don't.
Yeah, I just prefer pasta to not pasta.
Yes.
These are things where I'm like, even if I did have a least favorite that was more strongly worded,
Mm-hmm.
if you still gave me the option of do you want this or nothing or no pasta, I'd be like, oh no, I'll take it.
Yeah, I mean, I still got the pasta.
Yeah, but
But
there's definitely things where the opinion's strong enough where I'm like, oh, I would not eat it. You know?
I felt very disappointed about that. I will say I was very disappointed about that pasta because it had so much potential.
Yeah.
But so apparently, I do think penne is my favorite. I also really love tortellini stuffed with cheese.
Totally same. Yep.
You know,
Love it.
cheese ravioli. I mean, those are like. But then it's like, is it because of the shape of the pasta or the cheese in it?
Yeah. Yeah, that's a good question. I like tortellini a lot, and from the local Italian place that is kind of near my neighborhood.
Oh yeah.
I love their cheese tortellini with their pink sauce.
Oh yeah.
Amazing.
I love
Molto
their
bene.
cheese ravioli is the best cheese ravioli I've ever had. There's something about the cheese in it or the mixture that's so fluffy and good.
Mm-hmm.
Even just with regular old red sauce, it's just like the best. The raviolis themselves.
Mm.
So those are really good icebreaker question, Allie. We appreciate you.
Yeah, very much
And
so.
Write in and tell us y'all's favorite shape of pasta. And for our Italian listeners, we're sorry in advance for all the ways that we as people from the States butcher pasta.
Yes, we are very sorry. I have had, I guess, have you been to Italy too?
No, I haven't.
Okay. I have had what I believe is a very good version of the true Italian way, and I love it. And
Yeah, if you
know
want
that
to
we
fly
come up
us
short.
to Italy, we would love to. We'd love to experience Italian pasta. And on that note, thanks in advance for flying us to Italy.
Yes.
And thanks for all these questions. Those are awesome. We love having such good listeners that send in such fun questions.
And if you got questions in the future, you can reach out to us on our website at chemforyourlife.com to send us your questions, even if we're not just about to have our monthly Q&R and you think of one after you listen to this episode. You don't have to wait for an Instagram story or anything like that. You also get priority question asking through our Patreon. So if you want to support the show, help us keep the show going and contribute to cover the cost of making it, you can join our super cool community of patrons at patreon.com/chemforyourlife or tap the link in our show notes. If you're not able to do that, you can still help us by subscribing on our favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and J.M. Robinson. J.M. Robinson is our producer, and this episode was made possible by our financial supporters over on Patreon. It means so much to us that you want to help make chemistry accessible to even more people. Those supporters are Avshai B., who sent a question in today, Bree M., Brian K., Chris and Claire S., Chelsea B., Derek L., Emerson W. also sent a question in today, Hunter R., Jacob T., Christina G., Lynn S., Melissa P., Nicole C., Stephen B., Shadow, Suzanne S., Sam N., Stephen B., and Timothy B., who also sent a question in today. Thanks again for everything you all do to make Chemistry for Your Life happen.
We'd also like to give a special thanks to our reviewers who listened to this episode before it was released.